And that's a great segue as well into kind of like talking to the actual testing. So we talked about the concepts of it. What are some of the tools that you guys employ out in the field that help you determine your results?
Yes. So when we do resistance to ground testing or soil resistivity testing, we are going to generally rely on an instrument that is has some certain number of terminals on it, also referred to as poles. The fall of potential test is the kind of gold standard for resistance to ground of an electrode system, whether that be a single driven 10-foot ground rod or a 400 by 400 substation. Now there are alternative tests that are similar to fall of potential for scenarios like that. That is one of the probably the question that we answer the most here at AEMC Instruments is I have this giant thing I need to test. It has 50 ground electrodes. I can't do a fall of potential because it would require me to go super, super far, right? There are alternatives there. In the document that Tom mentioned, the IEEE standards that he mentioned reference those as well too. So we need some type of instrument to do this type of test. We need it to have some type of terminals. We refer to these as poles. 3-pole instruments going to perform our generalized fall of potential test. 4-pole instruments allow us to do soil resistivity. However, it's worth mentioning at this point, a 4-pole ground test instrument is a wonderful fall of potential measurement or resistance to ground measurement device when we're talking about something with very low resistances. The reason for that is consider that everything you connect to your instrument also incurs a resistance, especially when we refer to that connection to the electrode itself. So if I have my electrode, I have one lead coming off that electrode to my instrument. This lead has a resistance, and this lead is now a series resistor in that measurement. With a 4-pole instrument for resistance to ground, I can then eliminate that lead resistance by placing another lead in place there in the same location that my E lead or my green lead is placed. It's connected to my electrode, eliminating that lead resistance by taking a voltage measurement. So one of those, it's a quick trick here to ensure accuracy and to better perform the measurement is a 4-pole instrument is a lot more flexible than just a standard 3-pole. And most instruments out there, whether it's from AEMC or others, are 4-pole instruments.
Okay,
they're often just not utilized to their maximum potential.
What are some of the reasons you think are for that? Is it just a lack of knowledge?
Lack of knowledge. Yeah, read the manual, man.
RTFM every time, Tom.
Yeah.
RTFM, man.
That book.
To add on to that, Greg, I would say, and I'm going to give you a little bit of personal Tom talk right here, is if you ever see, like, I'm not picking on Megger. Look, if you could sell them, I understand that too. But Megger has like a DET 3/2. It's a 3-terminal test set, and you can get a 4-terminal test set for just I think about 10% more in cost. And so the cost increase versus the versatility that you get back out of it, it's absolutely a waste of your money, in my opinion, to spend it on a 3-pole test set. Just go get the 4-terminal one and have 5 more tests available to perform in your toolkit, right? Yep. Versus being limited only with, your 3-point tests. So the other thing I want to kind of highlight real quick, and Greg, I don't know if you have like a 4-pole terminal test set there, but if you look at those, that beauty right there. If you look at those terminals on the left right there, and some of you guys might be able to see it, at your own shops or whatnot, but every test set manufacturer calls them different terminals, ES or X or C. I'm not going to dive into what the difference is between all of them. There's usually 3 different formats of what they name their terminals. Fluke, Megger, and then I think there's one more. And anyways, if you just compare them directly to this guy right here, a 4-point ground test set is exactly like a DLRO with 2 potentials and 2 currents, except for it runs at 1,000 hertz AC or whatever frequency, right? That's the only thing. And it runs at milliamps. It's the exact same test set for the most point. When you do a fall potential, you just bond these 2 and you run it directly to your ground probe, You take this, your C lead goes out to your far probe, and your P lead goes out to your moving probe. And so it's the exact same test set. It's just that you need to perform it as AC in order to get an impedance measurement off of it.
Yeah, so to build on that as well too, that's exactly right. If I look at a 4-pole test instrument, and we go over this in the seminar, this is a multifunction instrument. It's going to perform soil resistivity testing, follow potential, both in 3 and 4-pole setups. This one can even test a transmission tower with our ground flex fuel kit. But end of the day, outer 2 are going to be current terminals, right? Inner 2 are going to be taking some type of voltage measurement. We have current flowing. We're creating a circuit. A voltage is then applied because there's a resistance in between here. A current begins to flow, and that current is then measured along the traverse between these 2 terminals. And it doesn't matter if it's soil resistivity testing, follow potential, the measurement is generally the same. To complement what you just said, because it's a wonderful observation. I've tried it. I've taken AEMC's version of the DLRO, the 6240, and I've done some just kind of shallow soil resistivity testing just to see if it's working. I'm not going to imply that you actually go out and do that. And the results are very, very similar. The difference, as you identified, though, one of the principal differences outside of those instruments, the DLRO not designed for that purpose, is going to be the fact that I'm testing at usually 128 hertz with an instrument like this as a square wave versus just a pure DC measurement. Those of you that are more familiar with soil resistivity testing specifically, you may be familiar with other more advanced instruments out there. The Mini Sting comes to mind, Super Sting, or the Iris as well too. Those are DC direct instruments that are looking for the decay of that DC current that was applied. It's a different test procedure, but very similar to a DLRO in that respect. A lot more test current being applied there. But the test instrument itself remains largely the same. We're using the same principles that we see show up in other test instruments, like for other resistance testing instruments, I should say there. The test instruments are going to be specific to the job. If you're looking for something that is going to cover all your bases, a 4-pole instrument is going to be the best.